Okay, so guys, in this video we are going to see what is the Mc Laurian series, and you know what, these series, the Taylor series and the Mc Laurian series, are actually not really important while you are studying differentiation. The only things which are important are the implicit differentiation, the chain rule, the derivative of the trig functions, the derivative of the exponents, and yeah, that's pretty much it if you really want to study differentiation. But yeah, these things, the Mc Laurian series and the Taylor series, are actually a part of differentiation, so we are going to study them. But yeah, I'm going to wind this Mc Laurian series in this one video. Okay, so Mc Laurian series is nothing, it's the Taylor series for which the neighborhood point is actually equal to 0. Okay, so instead of putting the value of a, you have to put in a 0 over there. Okay, so let's see, we have to find the Mc Laurian series for the sin x. N is actually equal to 0, 1, 2, 3, and this goes on till infinity. So let's take the first derivative, the 0th derivative. So the 0th derivative of x. So the 0th derivative will actually be exactly the same. It will be sin x. Then the first derivative. So the derivative of sin x is actually cos x. Then we have to take the second derivative. That is, the derivative of cos x is negative sin x. Then the third derivative. Derivative of sin x is actually cos x, but we are having a negative sign, so we have negative cos x. Then the derivative, the fourth derivative actually, derivative of cos x is negative sin x. But we already have a negative sign over here, so the negative will be positive, so we will have positive sin x. And I think so that's pretty much it. Instead of putting in some actual number, we have to put in the value of x as 0. F 0th derivative under the value of a as 0. So sin 0 will actually be equal to 0. Then the first derivative with respect to 0, the value of cos 0 is actually 1. The value of sine at 0 is 0. So we have a negative sign. The negative sign won't have any effect on 0 because 0 is a positive number. It will always exist in the positive format. The second derivative at the value of x as 0, we will have it as 0. So the third derivative at 0 will actually be equal to the value of cos 0 is actually 1. And we have a negative sign, so we will have a negative 1. The fourth derivative will of course be equal to 0. Okay, so now let's write the Mc Laurian series, and here's the formula. I would like you to write this formula on your own and then check my solution. So the function will actually be equal to the 0th derivative, which is actually equal to 0, plus the first derivative with respect to 0. So the first derivative is actually 1, x minus c. C is actually nothing, it is 0. So we can write x divided by the first factorial plus the second derivative with respect to 0. The second derivative with respect to 0 is actually 0. So 0 and x minus c squared. So c is 0. X squared multiplied by 0 will of course be equal to 0. Plus the third derivative. With respect to 0, it is actually negative 1. So we will have a negative 1. Then x minus c. C is of course 0. So we will have x cubed divided by third factorial. Now you can see the pattern. This is the 0th term. This is the first term. This is the second, third, of course the fourth term. We are already seeing this pattern that the even terms are having the value 0. So the fourth term will be 0. Thus the next term is the fifth term, right? And the fifth term will actually have a positive sign because the first odd term, it was having a positive sign. Then the third term, which is the next odd number, was having a negative sign. So the fifth term is corresponding to the first value. So we will have this as, of course, the value of cos 0 would be 1, then x power 5 divided by the fifth factorial. Then again we have the sixth term, which is an even number. We will have 0, plus the seventh term will have a negative sign, and we will have x power 7 divided by 7 factorial, and this goes on till infinity. So let's rewrite the Mc Laurian series while ignoring the terms which are necessary. So the first factorial, the first power with the first factorial, then we have the third with the third factorial, then we have the fifth, x fifth divided by the fifth factorial plus x7 divided by the seventh factorial, and this is the final Taylor series for the sin x. Now let's try to find the Mc Laurian series for Euler x. Now this case is actually very special. You know why? Because the derivative of Euler x is again Euler x. So if we take the first derivative, the 0th derivative, first of all, it would be the same thing. Then the first derivative will again be the same thing. Then the second derivative will again be the same thing. So if we put the value of x as 0 according to the Mc Laurian series, we'll have f0 with 0 value, we'll have e power 0, which will be equal to 1, because any term having an exponent 0 will actually be equal to 1. Then the first derivative at the value of z will be equal to e power 0, which will be 1. Then the second derivative, of course, will also be equal to 1. So how can we rewrite the series for this thing? If we just have a closer look at the Mc Laurian formula, we can see that the first term is 1. Then the second term is of course 1. But x minus c, Remember, x minus c power 1 divided by first factorial with 1. So this is the one right over here. Then we have x minus c. So what is the value of c? It is 0. So x power 1 divided by first factorial plus the second term, the value of the derivative is 1. X minus c will actually be equal to x squared divided by 2 factorial plus 1 x cubed divided by 3 factorial. And so now you can actually rewrite this series x4 divided by 4 factorial, and this goes on till infinity. So yeah, that's pretty much it for the Mc Laurian series. And now we are going to discuss the domain and range while doing the derivatives of some functions.